All right. So once I'm Jason, one of the founders at Arise, and Jack, feel free to introduce yourself.
Hey everyone, yeah, my name is Jack. I'm software engineer here at Arise. I've been working on testing out LLMs and time series in the past few months.
Cool. Awesome. Um, so first off, for all of you joining here, we do have an event in July at Check 15. So the full it's a observability and evaluation event. The full Shack 15 is going to be is basically taken over by us for a day in July, and there'll be research tracks, so researchers, research papers. There'll be technical discussions like this. There'll be builder discussions and customer overviews of products they're building. So quite a lot in this space. Is quite a lot of kind of in-depth topics, and we're trying to do this as like a really deeper, there's a lot of events going on that are kind of surface level. This is going to be a pretty deep technical event. So please reach out and check it out, and join us for that. So first off, what we were trying to do with time series evals is place a large set of time series in the context window of an LLM and see what it can find. Um, I don't know if Jack, if you've seen the like GPT-4 stock analyzers out there on Twitter. Um,
Yeah.
but yeah, and there's a lot of people like trying to use GPT-4 for a little of everything. I mean, it's a little, I feel like those might be a little snake oil salesmanship, but like, but there's a real deep question of like how, how well an LLM can look at time series data and understand it. Any other thoughts you want to add just to the pure context window time series questions we had? Yeah,
No, I think I think just trying to think of this as like another tool, trying to figure out how do we like tune this tool to work really well with time series. I think
yeah,
it's very still like pretty early on.
yeah, agree. And I think that like what the I mean, what would you say one of the disadvantages do you think of using an LM for time series data? What are the couple of drawbacks you can think of as you look at, you know, this option?
I mean, I really feel like one thing that's tough with LLMs. I think we've seen this in a few other cases, is just getting it to follow instructions. Saying like if it's above or below this threshold, or if it's above this threshold, tell me about it. If it's below this threshold, don't tell me about it. And I guess we'll see with kind of like the rest of this presentation, the instruction following isn't like fantastic. Um,
Mhm.
but I do think like the advantage is like it's fast, it's easy
Yeah.
to kind of experiment. You don't have to necessarily learn some sort of API in order to get started.
Yeah. And so one of the questions that hopped up too is like, okay, what LMs did we use? What are we doing here? These are out of the box, out of the box LLMs. So meaning Claude 3 Opus and GPT-4 from the probably the best out there industry wise. So could you fine tune to make this what we're doing better? Could you um go and I think this is one area, like I'm sure I'm not sure how much data they've been fine tuned on that looks like the data we're showing. So this is really kind of a what can you get with what's out there. It's also, if you look at a lot of teams, they're not fine tuning. They're just throwing data into GPT-4 right now, and they're kind of assuming it can find interesting anomalies or changes in that data. And one of the questions we had is, well, given teams are already doing this using GPT-4 and Claude 3 and some of these others, and they're just putting data in the context window, how good can we expect those to be at finding changes, anomalies, or synchronized events, anything in that data? So this is not fine-tuned LLMs. I think that's a one area of research that we, all of you who are listening could probably dig into and think about. And so we kind of hinted at this again, like what are we doing? There's a bunch of time series based approaches you could take in general Python and say on say time series data. And and these approaches, there, I mean, incredible number of time series anomaly detection algorithms out there that do lots of different that are extensive in what they do and detect. But the question's like, what's the advantage of just throwing data into an LLM? Well, the advantage is just that you can direct through instructions pretty quickly what you want it to look for, what you want it to ignore. It's human text, which you can describe those things. You can find correlations from different time series data by just, again, throwing it into the context window. And then it can format the analysis for you afterwards. So there's advantages if it works that have to do with like generalization, ease of use, abilities to just integrate into the systems that are out there easily. And you'll see the disadvantages are going to be results are not going to probably match, or not even probably, but results will not match what you could do if you just are looking for something very specific and hard coded, and or what anomalies you want to detect in the first place. It's also not scale wise necessarily in the order of magnitude of what you could do with probably some more traditional approach. So the number of time series we're talking about here at once in the context window, the 110K token context window can fit about 300 time series. So you're not talking about that many. We haven't tested Gemini 1.5 yet, so you might be able to get like maybe another 10x this into the context window. But basically what it is JSON data in the context window. How well can an LLM detect with very little work on top of it in terms of fine tuning or pre-setup?
Yeah. I kind of want to actually kind of touch on your point where you're saying it finds
Yeah.
correlations, and I think early on when we were trying to test how LLMs, just even view these
Yeah.
time series, we weren't. I don't think we were specifically asking it to look for like spikes over 10% like we have in this test, but even then we were passing it 10, 20 time series, and it was already automatically telling us, hey, it looks like there's these 2 or 3 spikes that are correlated across a few different time series. And the prompt mentioned nothing about tell me about correlation. It didn't mention anything about, find a spike over X%. So there's this kind of like, I don't know if we want to call it emergent behavior, but definitely it was kind of pointing out patterns that, with traditional approaches, you really have to kind of explicitly be looking for these patterns. And so I thought that was really interesting.
Yep. So I think that's exactly it. Like the generalization is like not having to specify or hard code or hand code exactly what you're looking for, and the ability to find generalized relationships that maybe you didn't would be hard to hand code into detections, I think are going to be advantages. And so going through, I'm going to hop first because there was a question here around what does the data look like. The data looks something like this, which is a description of the prompt, some JSON. So there's a dimension here which is a random city in the world. I don't actually know where Aarontown is, but there's a set of cities here that are random in the world, and there's just like 30 days of data for this city. Um, I'll show you Phoenix. So this is Phoenix, which is uh, which is our open source kind of tracking, tracing and tracking solution. And you can see kind of there's a bit of a prompt at the end around what you're looking for. There's some response, and you're asking it to kind of group by date what it sees and kind of what those are around the output. So this is kind of what it looks like from a data set perspective. It's JSON data and lots, 300 of these time series in JSON that you're just formatting into the window. LLMs work, and this is a pretty common approach these days. You'll find lots of people putting just JSON into the context window. The LLMs know and understand JSON really well. So not just time series data, lots of different data from general structured data. from to pedantic models to you name it. People are kind of doing JSON formatted data um, to basically fit into the context window. So this is kind of like not an abnormal, it's a pretty normal thing industry wise. I think what's new is kind of trying to test time series. So when you look at the data set, like when you look at like what are these results and what are we testing for look like, it looks something like this, which is there's a kind of a set of times. So every box here is a time series we kind of fit into the context window. And we test different sizes of context windows. So like this one's a smaller one, maybe 30K-ish. And so the gray boxes just mean it's kind of no anomaly was added to the data. It's just kind of noise. The red boxes are basically spots where there was an anomaly, a spike added to the data that GPT-4 missed. So this is an example of GPT-4. This is an example of Claude. These are examples where there's a spike in the data where it was missed, a spike in the data where it was detected, and it gives you an idea of like what this looks like. So noise, um, spike here detected correctly, spike here missed by Claude. And so it kind of gives you an idea right away that like first off, we're kind of surprised that Claude was better than GPT-4 at this. You know, uh the that's not kind of what we've seen not what we've seen everywhere. We've seen quite a lot of GPT-4 and GPT-4 Turbo as a go-to across a lot of tasks, but this specific task, which is I doubt is in the training set, or it's if it is, it's probably not pushed very heavily. It's probably a new type of eval task for these two models. um, any 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 thoughts on this, Jack? Um,
No, I think, yeah, everything you said makes sense.
uh, and so the so this is kind of these are kind of the setup. This is kind of one set of results, and we'll go into more details on like variations of the test, details of the data and time series and anomalies added, where it's failing, where the tests are, and I think like Jack, you kind of hinted at like there's a lot of variations of the data itself. Uh, this is one example. I think you hinted earlier that maybe we had thought like, okay, well maybe ranges matter in some way, or the size, or the where the spikes occur matters. Any thoughts on like why that you thought that might matter, the fractions versus non fractions?
Yeah, it, I think the tough part for LLMs is just doing math.
Mhm.
Um,
Yep.
and honestly, I think I'm not 100% sure, why. I think it was lower scales, 0 to 1 works, or higher scales, 1 to 100 works better than 0 to 1.
Yep.
It's not entirely clear, I feel like. Maybe it's just, the math comes out to be the same, but it's not really using math to detect these spikes. It's maybe just kind of looking at the number as if, it's a person eyeballing it. I think honestly that's maybe the best um, way to kind of almost interpret or put yourself in the mindset of an LLM. Is like, if you were just a person eyeballing these numbers, could you detect it? And what would be hard and what would be easy
Yeah.
to like find for you?
And I think the one also thing comes to mind as we were testing this, and we'll show you. We do have tests on like 0 to 1 values as well as these larger values here. And there's just probably something else around tokenization where I'm not positive like tokenizing the fractions. Like we've seen this in other tests where the 0 to 1 range, like a probability range, a continuous range, like the 0 to 1 range doesn't feel that discrete. And when you're talking about like in the end, these values, every single value gets tokenized. And the question's like, well, what are those tokens? What do they mean? And how does it compare one token to another? Like there's something about 0 to 1 ranges and the continuousness of it that I do think the LLMs struggle with. So worth noting, you don't, results may vary, and we'll show you some of the some varied results on kind of smaller, more 0 to 1 probability like ranges versus these larger ranges. First off, you have some noise. So there's settings in the test we have that we can set the noise level, the random noise level of the data, and then we can spike it on a day, and we can figure out how long we want that spike to be. The longer the spike, the better the results typically. But you can kind of add noise, add a spike. So this is kind of the simplistic test that was done for this. And and you could do, yeah, and there's questions around like multimodal. We are adding more tests to add more anomalies to the data, more distributions to test. Currently, it's like the results we're going through today is kind of more simple. Like, can it tackle this simple base case of what one event across the data at one time period, and how well does it find it? So first off, what do the results look like? Well, the lower noise levels were harder to detect. I mean, the lower values were harder to detect. So when you look at like GPT-4, that 50% spike, pretty bad results overall. I mean, I think I think for if for those stock picking, like would you want this picking a stock if if it can't pick out like pretty simple, pretty basic movements you can see with your eye? I think there's a big debate around, I think there's a fairly large area of research to do around like how well these will find patterns in data, where it's going to miss, where it's going to find it. So this is a pretty basic case that struggled with kind of some basic data. Now Claude did decently better than GPT-4 at the 50% spike level. Still, at the top range, still has work to do, but definitely better results. And you notice here these pink squares. These are kind of false positives, where it thinks there's a spike in a box, and it's not. So not only is GPT-4 not quite as good as Claude here, it's also like getting more false positives. As we move that spike up, so this is the 90% spike, these results get much better. So as the difference between those gets bigger, it is able to start to detect it. So it's, it does, like, and this gets better, this is actually pretty decent results, given like no fine tuning, no work on the data, just putting the template together for this. So anything else to add here? Like what I guess Jack, what we did kind of decide to also think about like standard deviation, and adding adding more information to the time series itself that's pre-calculated. Any thoughts on like why you kind of thought to do that, or what and we'll go into kind of what that is in a minute, but what's some of the impetus for adding some more knowledge to the data before,
Yeah.
prior to calculation, you're asking Claude and GPT-4 to do?
Yeah, I think it has to do with like the background level of background
Mhm.
noise that we have in the data. And sorry, I don't know if you already said this, but we're using a 30% kind of variation as the background. Um, and it felt like often, especially with smaller spikes, that it would just, catch spikes that are part of the background noise. It would say, it looks like the spike is on this day, but really it's just, part of that 30% variation. It doesn't really look further and see, there's a 50% spike or 90% spike later down the line. We thought, adding standard deviation, it's almost like, we pre-calculate the standard deviation, and obviously when we calculate, we look at the whole time series. So it's almost in a way kind of like we look at the whole time series first for the model, and we say this is the, this is the level of background noise. I mean, basically the standard
Yeah.
deviation that is typical in this data set, and
Yep.
to kind of tell it upfront to ignore this 30% noise that we added to the data.
Yeah, and I exactly. So, and I would add, like, when you look at this numbers, this, the I think Claude 3, as you kind of look at this, you kind of you see with very little work, very little effort, it's already doing something pretty decent. It's finding this spike in the pattern and data. It's detecting it. It's just doing it with a template. And the difference between GPT-4, maybe Turbo and Claude, might just be a slight head, a little bit of generation, in terms of like parameter, like Claude might be bigger parameter wise than GPT-4. I think you can extrapolate out and just say, where do we get in a year? Or where do we get in 6 months? And you can start to say, well, maybe these models actually get really good at finding these patterns, especially if you fine tune. Or especially if someone decides to fine tune on this data, or maybe make it part of the general data sets. So the fact that, like, these aren't, I think there continues to be more and more examples that these aren't just, parrots repeating words, but they are actually finding patterns and understanding data in some way and able to generalize at least some tests or some things that you're doing. I think there's continued arguments for that. So this gives you an idea of where I think the the space is going in terms of performance wise. And then Jack was just mentioning the standard deviation. We decided to add this. So the next set of tests and examples we give, we added a little bit more information around in a header area in the data set itself. So there's a question like, these LLMs maybe aren't great at doing like this complex math on the data. Like, why not just add it in the header information that you already have, so that the LLM has a little bit more information to help find odd patterns or things that stand out or are different. So this is an example of like other information you might add to then see if it helps the LLM understand what an anomaly is, or how things are different, or find generalized patterns outside of what you're doing. So this kind of gives you an idea of of what this looks like. And there's a question here: are you using natural language prompt or something, a prompt template? Yeah. So the prompt template is, so there is a prompt template here where the template, actually, we're filling in these time series data sets, and we're kind of making each one look the same, but there's, it is natural language. It is describing like what we're looking for, describing a bit around what anomalies and how stringent of a movement you're looking for. So you can dial in the detection strength by basically adding to the template around the data. And with these, like, you can see the 50% spike actually improves a decent amount with just adding that standard, a little bit more statistical information to around the time series itself. So there's, I think, a big hope, big possibility here. One, these models get better. Two, you add enough little bit of like the things that the models aren't great at, which is arithmetic or math, maybe you do a little bit ahead of it by adding that statistical information to the header around it. And then the things that the model's really good at, which is, I feel like, pattern recognition, like finding patterns, finding correlations, generalizing across patterns, being able to control that with instructions. Those are the things that these models are pretty good at. And so maybe you let them do the pattern recognition, but you do a little bit of the math up front to get this. So once again, standard, we added a little bit of header information around statistics of the time series in front of each one of these time series data sets. Cool. And that's, I think this was pretty easy to do. The standard deviation was pretty easy to do. You know, Jack, any other thoughts on this? Like, there's probably other things we could decide to add to that header, statistics or information around time series data that, like, you probably get this more complicated. There's probably a lot more
Yeah.
different data different statistics you can add. But once again, the reason to add this is like if you don't add this, it's got to do the math itself.
Yeah,
And
I mean,
yeah,
oh, sorry, go ahead.
no, go ahead.
Yeah, yeah, I mean, I think we talked about this a little bit, which is, let's start with something really simple. So like a single line standard
Yeah.
deviation. And I think, maybe if we want to get to 100% accuracy, for example, we can just write the change, from one day to another. And, say on April 5th, this value is 10% higher than the previous day value. So you can go all the way to the other end and pre-calculate everything.
Mhm.
Um, and, maybe there's some way in the middle where you don't blow up your token count, you're not doing all of the math, but you kind of get to like a 90-95% accuracy consistently. So I feel like there's a lot more that we can test out here, basically.
Yeah. Um, so it gives you an idea. And then there's a question of like, are all ranges equal? So this is kind of what we were hinting at before. And notice the values here are from 0 to 0.5 in this time series. And if I go back to this one, the values were from like 20 to 40, 20 to 30. So I'm picking different ranges now, which normally is not a big deal for some of the other analysis you might do, but for for time series data, and just knowing LLMs, we've kind of seen other problems in other data sets where there was challenges with just fractions, y-axis values and fractions that were output. And these and so that part of this was let's go test it. Let's go see this. And there's still so the work here, so the big kind of thing here is there's definitely work to go. Like these results were much worse in this range than the original range. So you can see this versus where you were previously on the others is a pretty big difference. So not all ranges right now, and I think this is a general problem for, I mean, these fractional continuous ranges for LLMs are generally problematic. And my hope is I actually think there's a lot of work and a lot of thought people are doing on trying to fix these. But this gives you an idea of some of the tests that we're doing and some of the results across these. So not all ranges are equal. Hopefully some of the work that's being done for the 0 to 1 range in general of improving the LM work, LM results will actually translate into this.
Yeah, actually, while you were talking, you mentioned earlier, like maybe it has to do with the tokenization
Yeah.
and how it differs between decimals and I guess just like whole numbers. I was testing this out in the background, and yeah, you're right. Like, something like 45, it tokenizes to a single token. But something like 0.45, it actually turns out to be three tokens, the zero, the point, and then 45 afterwards.
Mhm.
So, it's just kind of interesting that they're tokenized completely differently, even though all the only difference is like scale. So maybe that's something else that we can try out is like, how do we represent decimal numbers maybe in a better way?
Yeah. Yeah, I mean, you probably could just multiply by 100 on the decimal
Yeah.
side and get better results than we're getting here. So I think there's definitely work to do as you think about continuous ranges for these models. Um, uh, any other things to add, kind of challenges you kind of ran into, Jack, along the way? Um,
Um, I mean, this is a little bit
mhm.
no, you know what? Let me save this for I think you have a slide that kind of
Yeah,
talks about this a little bit, and then I'll bring it up.
cool. Give me 1 second. Any questions from the, I know people are just dropping questions in the chat. We'll kind of let me see if there's any of these we didn't get to yet. Um, how do we know the models are not writing code um, behind the scenes to find anomalies? As you know, GPT and Claude are not just LLMs, but systems doing tooling. I think, I mean, obviously we don't know everything that goes on behind the scenes, but I think typically with the API interface that we run across, so you can actually use GPT-4 in the user interface. Typically, it will show if it's generating code using the analyze. You'll see like this analyze thing hop up, but in the API interfaces, typically you're just getting kind of responses back. So could they be writing code in the background? Possibly. If you use the analyze, if you ask for code from GPT-4, normally it's much slower. So like the difference between when GPT-4 writes out code and executes it could be like 10 to 100 times slower. So it's also fairly noticeable when that's occurring. I don't think this is I would venture pretty high guess that that's not what's going on behind the scenes here. Um, on these, like, just responses are typical response times, as you stick in text to response. The APIs, I'm pretty sure you have to use the assistance API versus the chat completions API to get the normal code execution on GPT-4. So this isn't code magic, I don't think. This is kind of LLM magic. Now, could there be math coprocessors that call a calculator for some of this stuff when it notices math in the middle? I think that's very possible. That's probably executable in line at the speeds that we're seeing. I wouldn't be surprised if some folks do math coprocessors at some point. And then possibly you end up with code coprocessors, but the speed of execution right now when we see that probably means I don't think that's what's happening. But good questions. Good questions. And then yeah, and then there was a last one here, maybe and this is one where we originally had a bug where we synchronized a bunch of events in the context window, synchronized a bunch of these time series, and it was able to catch, and the results were actually pretty good. Like the more time series that synced up, the more it detected all of them. And then by randomly skewing the time series in time, where the events occurred, you're seeing the results that you see today. So there's something, there's basically leaking data into or leaking information into the tests can be careful. It will pick up on anything that you leak. This is kind of leaking the date and the movements on a certain date ended up being the thing it was looking for versus the spike and being able to catch it in the data. It could be an advantage. Like if you're looking for patterns across data that you don't want to explicitly have to define, it will definitely find patterns. And I think that could be an advantage. So if you want to actually find some general set of patterns and have it surface those, I think that if you're looking for fraud in data, I think there's huge potentials to find correlations that you would never explicitly type out.
Yeah, it's very good at finding correlations. I think, it just kind of will mention these are correlated or these appear to be correlated, I think, without even prompting it. I think what we found, it's actually interesting because, you think, okay, it's looking across multiple time series. It can like synthesize multiple time series at once. What we actually found was actually much harder was, having almost like logical operators between time series. So like, if this time series, it looks like it's spiked, but then there's another time series maybe right below it that has some value below 100, for example. In my prompt, we would say, if this value is below 100, ignore the spike. And what we found was that kind of instruction was actually very hard to get it to follow. Like, sure, these are actually correlated, and you think that the correlation, its ability to correlate is kind of generalizable, but it seems like it actually wasn't able to kind of like follow instructions about these correlations. So I think that's something else that we want to actually test out is more than just correlation, but like can it analyze two time series at once and kind of understand them together? haven't been able to kind of figure out like the right prompt or the right techniques just yet.
And in any thoughts on like how well instruction followed too? By the way, I was going to show a time. Someone asked a question about time series forecasting. We dropped a link to, I think Vibu from our community actually dropped this in the other week. But there's an interesting time series foundation model for forecasting using LLMs or basically transformers under the hood here that looks promising. So worth taking a look at. I don't know how many people are actually doing, time series forecasting with LLMs. The one challenge with LLMs in general or transformers are the speed relative to like maybe other techniques. But did want to drop that to the group here for people to check stuff out. How well did it follow instructions? I guess yeah, like that was another thing. Did you feel like it got worse at instruction following as we put more time series in the context window or about
Yeah,
this?
poor.
Yeah.
I think yeah, certain instructions like ignore if you see a spike, but the absolute value of the spike is, let's say, below 100, ignore it. Sometimes it would ignore it. Sometimes it would say that there's a spike, but it's below the threshold. Therefore, the user should ignore it. And actually, to the question of like, what prompting techniques are we using? I don't think we tried necessarily examples, but I guess in terms of chain of thought, like we did ask it to kind of show the math uh, and then use that math to actually determine like, is this spike above like 10%, for example. So, chain of thought definitely worked pretty well, but at that point, you're kind of talking about more tokens, slower response time. Maybe this is not something that you necessarily want to, eventually show an end user. Um, so sorry, getting back to like instructions. One thing that I think obviously, repeating instructions works really well. One thing that, just anecdotally I've tried that feels like it works well is putting the instructions right above the time series. So instead of like at the very top, here's a ton of basically tokens worth of time series, maybe instructions at the bottom. Putting the instructions above each time series seems to work a little bit better, but of course now your prompt is getting very verbose. You're kind of adding a lot of tokens maybe unnecessarily. So another avenue to kind of test out.
Yeah, and the question's like, someone's also questioning on bigger data sets. These aren't that big relative to the number of time series we're looking at once. So think of it as like very small relative to what traditional people might do for large scale fraud, for example. So we're talking about hundreds of time series here, like 300 plus time series, like 30 days worth of data. So it's not that much, but you look at Gemini and some of those context windows, you probably could do 10x that. Um, I think you could easily 10x these tests, but the question is like the point that I think Jack was making on some of the instruction following versus number of time series versus prompting techniques. Like the chain of thought, typically you're asking it to do something, and then by doing it, it makes the probability of it just reinforces its answer to be more correct typically. So like show us the calculation for the spike. But you can imagine as that the number of time series gets to hundreds and hundreds to thousands, showing that math is a lot. So some of the techniques that you might want to do just don't make sense as the data as you get more time series here. So hopefully that kind of gives folks an idea. Questions. So another question here was like, what are your thoughts on leveraging RAG architectures to better fine tune time series models? I'm curious about drift detection across time series, past versus current data, in addition to anomaly detection. Yeah, I mean, I think we're generally as a team more I think we see RAG much more used than fine tuning out there in the ecosystem. So it's kind of the right thing to jump to on 95% of use cases that are like custom data. Now this is probably one use case where the mod like fine, it's not often I say, fine tune might be the right thing to jump to, but like I do think that these models probably aren't fine tuned on doing these techniques right now. I think you might get something out of doing a fine tune on the time series. I think retrieval and RAG, maybe if you're trying to find examples that it's trying to detect. So like, if there's other examples in your data that you're trying to fit into the context window. So I don't know. I don't know. I think retrieval and RAG, not something I was thinking about for this. And again, it's probably the opposite for most use cases out there in the ecosystem. Uh, but yeah, I'm not totally sure about the applicability of retrieval. It just comes, retrieval is typically if you have your private data and you're trying to like window down that data to what to fit into the context window to help it answer the question. And so if there's other examples of time series from your past data sets that you're trying to detect, that could be it. But the question is like, do you need full retrieval on that, or do you just have like 10 examples that you just fit in every time? So I think that's probably where RAG would make some sense. And then, the fine tune would just make it better at this whole task, hopefully, in general. And my bet is the model providers end up adding these type of time series tasks into their foundation model builds, and these just generally get better at this type of thing, which is pretty new for an application perspective. Cool. And yeah, and so let's see if there's anything else in the Q&A or questions here that we might have missed. Are you looking at natural? I think we got to most of these. What prompting techniques using chain of thought? Yeah, I think we got to most of these. What are the use cases that you believe research in LLM time series is worth investigating over traditional tools, models, classical one? I think that I'm seeing across an immense number of customers, just like this example that I had of just putting JSON into into the context window here is like everyone's doing this. And I think anywhere where we can figure out the bounds of what the models can or can't do with this data, I think there's an assumption, or there was maybe assumption last year that like just stuff data in the context window and it's going to figure everything out. I think that understanding the bounds of what it can or can't figure out is still a pretty open question. These tests are fairly simple in their first incarnation. So I think there's a lot of research around what can or can't they figure out? Does it improve with with either fine tune or examples that you're trying to match against? Yeah, and how well can it follow instructions with lots of data in it as well? So those are the areas that like I feel like are super open in terms of what to go test and build upon. Cool. Well, thank you all. I mean, this is this is kind of a awesome to have so many people show up, and we'll continue. I think if you follow Aparna on Twitter, she's one of the co-founders of Rise, tends to put out a lot of this research. So a lot of this stuff comes out of her Twitter account. Follow that, follow Aparna on Twitter, and we'll drop it in the we'll drop all this details and decks and materials into the community of Arise, and we'll continue to put out research that we find and see that we see that we think adds to how people should use this stuff in the ecosystem. Awesome to see everyone. Thank you for joining. Thank you, Jack, for going through.
Awesome. Thanks, everyone.